Alright, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, in this session, we are going to discuss further the motion in the straight line. Okay. So, in the last session, guys, I'll just introduce myself. My name is Dr. Umashankar, and I am your physics educator. Okay. Okay. So guys, so in the previous session, beta, of the motion under motion in the straight line, we have done the motion in the constant gravity. Hello, Shita. Okay, and afterwards we have seen the topic of motion in a plane, that is the projectile motion. Okay, now again we are coming back to the motion in a straight line, and we are going to one concept, very small concept of relative velocity. So basically, you are going to see this relative velocity in two dimension also. Okay, but right now we are going to see this in 1D only. So relative velocity in one dimension, that is when linear velocity happens to be in one direction only. Are you getting my point? Okay. Now, what do you mean by relative velocity? See, basically, the main important thing here is the frame of reference, right? So whenever motion velocity is a representative or a representation in a way to some motion. And motion, if you want to see a motion, or if you are talking about the motion mostly depends upon that from where you are observing that motion. Okay, like for example, we know that earth revolves around the sun. See, very basic example of it that we can see practically. Earth revolves around the sun. Okay, we all know it. This is common knowledge. Okay, but from the frame of reference where we are observing the sun, it seems that the sun rotates around us, right? Yeah, isn't it? So basically, the motion very much depends upon from where you are observing it. Okay, from where you are observing it. Like for example, if I say that someone is moving from this position to this position, right? Now, what kind of a motion is this? What kind of a motion is this? What do you say? How it seems to look like? Hmm? Let's suppose a person moves from point A to point B. Okay. Now, what kind of a motion is it? Can you answer me? Can you answer me? Yeah, from A to B, what kind of a motion is it? Now, many students would say on this is a straight line motion. Okay. Now, when you see straight line motion by default, by default, you are observing it from here. You didn't given any attention to the observer. Now, if a man moves on a straight road, and if the observer is sitting on the moon, and from the moon he observes a person moving around a straight road. Okay, it seems to be in rotation, isn't it? It will look like in rotation. Do you agree to it or not? Yes or no? Okay. Do you agree to or not? Definitely, sir. Definitely, sir. So, see, what I'm trying to tell you, see, motions, first of all, try to understand the concept of relative velocity, because in the same panel, we are going to do in the two-dimensional also. Okay. Okay. So, see, motion very much depends upon one thing, that see what kind of a motion is it. Rotational motion, is it linear motion, is it rolling, is it combination of linear circular motion? Whatever motion is there, it always depends upon from the basic of frame of reference. So motion basically, yeah, we can say the type of motion also, the type of motion is depending upon the frame of reference. From the frame is depending upon the frame of reference. That means from where someone is observing the motion. Okay. So that is in like common terms of physics, we say observer. Okay, observer. Like for example, let's suppose, now let's try to firstly understand this thing, because see, if the concept is clear, and if you say, I'll tell you one method of, finding the velocity in two dimension, eye center method, instantaneous center method. I don't know if we know it or not. Okay, like very interestingly, many problems can be solved through that also. I'll give you some glimpse of it also. Okay, okay. Now let's suppose that there is, there is a ground, okay, and a person, let's suppose A, or let's suppose B, is standing on this ground, okay, and someone is moving. Let's suppose he's having a cart or something, a wheel or something, okay, and this is a person. Let's call him A. Let's call him A. Okay, let's call him A. And let's suppose that this trolley, let's call it T. Okay, this trolley is moving at a velocity of 10 meter per second. Okay, so we say Vt is equal to 10 meter per second. The velocity of the trolley is 10 meter per second. Now listen to me one thing very carefully. When something is written like this, when something is written like this, like Vt, Va, Vb, by default, if nothing is mentioned, you consider this velocity with respect to the ground. Okay, what ground? The ground of the earth. Are you getting my point? Which we assume to be assumed to be at zero velocity. Are you getting my point? Okay. Okay. So when you are simple fundamental, when you are observing some motion, the velocity of observer becomes zero, right? So when we write VA, VB only, VT only, VX, VY, whatever, it is always with respect to the ground. Okay. Now the right way of saying this, like let's suppose there is a person, he's standing on the ground, let's name him B. Now there is another person A, he's on a cart or on a trolley which is moving at the velocity of 10 meter per second with respect to ground. Okay, so whenever I write something like this, okay, whenever I write something like this, you consider that this is velocity with respect to the ground. Okay, now when B is observing, now please understand this. So I can say that what is the velocity of A with respect to B. So when I write VAB, when I write basically VAB, so what does I mean? So I mean velocity of A. See, see, all these terms are to be understood very, very clearly. So velocity of A with respect to, this is what, with respect to B, with respect to B. So when I write velocity of AB, what does that mean? Velocity of A with respect to B. Okay. When I write velocity of B with respect to A, it will be, see, BA. So it means, see, many students confuse in this. Very simple topic. It's extremely simple. Just you have to understand quite a few basic. We need some discussion on it. Okay, so don't feel that this is going too slow, because see, many students are getting confused in all these things. Okay, now velocity of B with respect to A. So velocity of B with respect to A. When we write VBA, so that means velocity of B with respect to A, right? When I write only VA, okay, so this is velocity of A with respect to ground. Velocity of A with respect to ground. Okay. Okay. And ground, we assume that this is the ultimate reference which is supposed to be fixed. Okay. So this nomenclature wouldn't, worry you, right? You understand this nomenclature? Now please understand this. So when I say velocity of A with respect to B, that means that velocity of A as observed from the B. Are you getting my point? Please understand this again. When I say velocity AB, that means what is the velocity of A when observed from the B. Okay. And obviously you understand that velocity is a vector. So you need to have the magnitude, you need to have the direction. Like for example, so when I say velocity of A with respect to B, so I'll just write it again. So velocity of A with respect to B, it means that velocity of A. velocity of A as observed, as observed from B. Velocity of A as observed from B. Okay, as observed from B. So B will become the observer. Okay, so all of you students can respond to me if you have any doubt in this. Now, when I say that, let's suppose there is a person who is standing on the ground, okay, B, and there is a person who is, moving over a trolley whose velocity is 10 meter per second. So the velocity of the trolley with respect to ground is 10 meter per second. And there is a boy who is standing on the trolley. Who is standing on the trolley. So what is the right procedure? I'll tell you first the right procedure, then we'll take the shortcut and everything. Let's understand the right procedure. So we want to find the velocity of A with respect to B. So how I am going to write it mathematically? I'll write it like this. Velocity of B minus velocity of A. Velocity of A minus velocity of B. Are you getting my point? Velocity of A as observed from B. Is it clear, beta? Please answer me. Okay, velocity of A as observed from velocity of B. Now please understand this. When I write velocity of A with respect to velocity of B, that velocity of A minus velocity of B. So what does that mean? So velocity of A means velocity of A with respect to ground. Velocity of A with respect to ground, and velocity of B with respect to ground. So velocity of B with respect to ground is 0, right? Velocity of B with respect to ground is 0. Okay. Okay, how come it is 0? So velocity of B with respect to ground, when you write velocity of B with respect to ground, when you write, so you will write velocity of B minus velocity of ground, isn't it? Okay. Okay, so velocity of B is 0, velocity of ground is 0, so that is going to be 0. Yes or no? Please answer me. Please tell me. Right? So velocity of B is 0. Now, what is going to be the velocity of A? What is going to be the velocity of A with respect to ground? Velocity of A with respect to ground. Okay. So, what is going to be the velocity of A with respect to ground? Right? So, velocity of A with respect to the ground is going to be clearly 10 meter per second, isn't it? It is going to be clearly 10 meter per second. Do you agree or not? Please answer me. Yeah? Hmm? Please answer me. Yeah. Because see, simply if you use a little bit logic, because otherwise we can do it in mathematical way, but this is very simple. Na? A is on the trolley. So basically trolley and A, they do not have any relative velocity, isn't it? Isn't it? Please answer me. Do they have any relative velocity? No, sir. They do not have any relative velocity. Isn't it? Isn't it? Right? Okay. So now what we are going to do, we are going to write velocity of A here is 10 meter per second. And so what is the velocity of A with respect to B? Velocity of A with respect to B is going to be 10 meter per second, and the direction of it is going to be this way. Isn't it? Very, very simple. Do you agree or not? Please answer me. So this is the velocity of A when you observe from B, right? Very simple, isn't it? Okay. Now again, if I just give you one more thing. So let's suppose both A and B. Now let's suppose both A and B, right? Let's suppose both A and B now are on the same trolley. Both A and B are now on the same trolley, which is moving at a speed of 10 meter per second with respect to the ground. Now, what is going to be velocity of A with respect to B? Okay, so you will write velocity of A minus velocity of B, isn't it? Velocity of A minus velocity of B. Now here clearly velocity of A is also 10 with respect to ground. Velocity of B is also 10 with respect to ground. So their velocity is going to be 0 because they are on the same trolley. So there is no relative velocity between them. Okay, Shweta. Right? Like in a similar way, when you are in a train, okay, when you are, so I hope all of us have traveled in the train, bus, car, anything. So when you are traveling in a train, the person sitting in front of you is in the same velocity as you are. So the relative velocity between you and him is going to be 0, isn't it? Okay, if you are traveling in a train with a person, okay, with your one of your friends, so both of you with respect to ground is moving, okay, but the relative velocity between you is going to be 0, right, because you both are moving at the same velocity in the same direction. Are you getting my point? Now one key point here is, yeah, one key point here is, see, See, for relative velocity, so see, all these key points are going to help you in solving questions. Okay, we'll move towards each anything, we'll do everything. So for relative velocity to exist between two bodies, between two bodies, between two bodies, their velocities must be different. Their velocities must be different. Okay, their velocities must be what, must be different. And when I say velocities must be different, so velocity is a vector. So if two bodies are having two different velocities, so either their magnitude is different, either their direction is different, or both magnitude and direction are different, then only the relative velocity will exist between two bodies. Is that clear? Let's suppose two bodies are having the same speed, but they are moving in different direction. Will they have the relative velocity? Will they have the relative velocity? Like for example, if I say, see, if I say a person A, he is moving in this direction with a speed of 10 meter per second, and if a person, let's say B, okay, he is moving in the 10 meter per second. So will they have any relative velocity? Oh, okay, okay. Please watch the recording then. Please answer me. Will they have any relative velocity? Will they have any relative velocity? Please answer me. No, no problem, no problem. Will they have any relative velocity? Right? No, they don't have any relative velocity. No, this is wrong. They have the same speed, but they have different velocities because their direction is different. Their direction is different. So how we are going to do that? So if I write VA with respect to B, VA with respect to B. Okay. Now VA with respect to B. So this is going to be VA minus VB. Now this is going to be VA. So VA is minus 10. So how come it is minus 10? Because see, direction of motion we understood now. If the motion is happened to be in negative x direction, so motion, direction of motion is given by the direction of the sign of the velocity. So if the motion happens to be in negative direction, in negative x direction, it will give you the negative sign. So this is minus 10, and this is going to be minus, and this is plus 10. This direction is plus 10. So what we are going to get? We are going to get minus 20 meter per second. Minus 20 meter per second. Are you getting my point, beta? Are you getting my point? So velocity of A with respect to B. Velocity of A with respect to B here in this case is going to be minus 20 meter per second. Okay. That means when, now please try to visualize this. Okay. Let's suppose there are two persons like this. Okay. And they are moving apart from each other. They are moving apart from each other. Now, if you are observing this person, that is the person A from the B. Okay, so now when B look at A, how he feels. Now he moving in this direction, this is moving in this direction. Now let's suppose if B would have been not moving, he must have seen that A is moving away from him at a velocity of 10 meter per second. But now he is also moving away from A at a velocity of 10 meter per second. Now, when you observe the motion of A from B, it will look like that A is moving at a speed of 2 meter per second away from B, right? Okay, see, this is 1%. You try to visualize it. Okay, see, this visualization is very important because I'm just going to give you one shortcut. Okay, to get the relative velocity. Okay, we can do this way also. We can do by the shortcut also. Any way you want. Right now, please observe. These 2% are there. 1% B, 1% A. This is having a velocity of 10 meter per second in positive direction with respect to ground. This is having a velocity of 10 meter per second in negative direction with respect to ground. They are moving away from each other. Now, when you are observing from B, B is observing A, B is observing A. So when B is observing A would seem to be moving away at a velocity of 20 meter per second. Isn't it? Isn't it? Very logical. Like same thing you can think like two trains are crossing each other. So if you ever traveled in a train, you see outside the window, and if another train is going in the opposite direction, you would see that it is moving at a very high speed. It seems, isn't it? Have you ever felt that? Yes, so we have felt that. Why so? Why so? Now I tell you why so. Now see how we are going to do it. Anyways, so see we have the A and this was B. This was B. Now see, this is moving in 10 meter per second this direction. This is 10 meter per second this direction. So one way you could do like this. Now you think this way. Now please understand this. Now I want velocity of A with respect to B. Okay, so B becomes the observer. So what is the shortcut? The shortcut is that when B is becoming the observer, when your B becomes the observer, what you are going to do? When your B becomes the observer, when B becomes the observer, you are going to make the velocity of B zero. You are going to, because it is he's the observer now, so you are going to make the velocity of B is zero, and you are going to add the velocity of B to A, but in the opposite direction. Please listen to me again. When we are observing A with respect to B, that means B is the observer. You are going to stop the B for that moment and you are going to add the velocity of B into A but in the opposite direction, right? So I have stopped the B. I have stopped the B, stopped it for a moment, and this velocity I have added to A but in opposite direction, 10 meter per second. So you are going to get the same thing, that is 20 meter per second. Okay, in a negative direction, so minus will come, isn't it? Minus 20, so both of them added 10, 10, that will become 20 meter per second, isn't it? Isn't it? Now in the same way, let's suppose A is there, B is there. Okay, A is there, B is there. Okay, now see, this is moving at a velocity of 10 meter per second. This is moving in this velocity 10 meter per second. Now, if I write velocity of B with respect to A, okay, so how I am going to do it? So if you want to do it quick, what you are going to do? So now A becomes the observer. Who becomes the observer? A becomes the observer. Now when A becomes the observer, you are going to stop him, make its velocity 0 for the moment. Now you are going to take this velocity, you are going to add this in B but in opposite direction. You are going to add this in B but in opposite direction. Okay, so this 10 meter, it reverse, it will become 20, and since it is in positive x direction, you can right away write plus 20 meter per second. Or you can choose to do by the conventional way. Velocity of B with respect to A is velocity of B minus velocity of A. So velocity of B is 10 minus 10. So this will become 20. You are going to get the same thing. So either you can understand the velocity like this conventional way, or you can understand the velocity like this. Okay. Okay. I hope it is clear to everyone. Right? Okay, and now same thing happens for the acceleration also. Okay, let's just give you a brief about the acceleration. Now if I talk about the relative acceleration, again it is going to be in the same way. relative acceleration. Okay. Okay, so relative acceleration. So I'm hoping you are getting the feel. Now see, and now this velocity funda we can apply here also. Na? Now see, velocity of A with respect to B. So B is the observer. So B velocity is already zero. And A is moving in the right direction. That is in positive x direction. So right away it is going to be 10. Right away it is going to be 10. Isn't it? Okay. It is going to be 10. Okay. Okay. Right. Now here you can do so both velocity f a and b both are in the same direction 10 10. So if you observe one with respect to the other, both velocities are added in opposite direction, it becomes zero. So the relative velocity is zero. So same funda you can use wherever you want. Now same thing happens in the case of relative velocity. So let's suppose we have a person relative acceleration. We have a person sitting on the ground, and again we have a trolley. Okay, we have a trolley, and this person A is moving at an acceleration of 1 meter per second square in this direction. It has a acceleration of 1 meter per second square in this direction. Okay. Okay, so now in this case, what is going to happen? In this case, what is going to happen? So it is going to, so if I want to have the acceleration of A with respect to B, so what is it? So it is going to be acceleration of A minus acceleration of B. Okay, so this is going to be 1 minus 0. 1 minus 0, so we are going to get plus 1 meter per second square, that is plus in the positive direction. Is it clear, Beta? Is it clear? Now let's suppose both A and B are on the same trolley. Okay, both A and B are on the same trolley, right? Okay, A is there and B is there. Okay, both of them are on the same trolley. So when both of them are on the same trolley, and let's suppose the trolley has the acceleration of 1 meter per second square, that means A is also having the acceleration of 1 meter per second square, B is also having the acceleration of 1 meter per second square. So what is going to happen? What is going to happen then? So what is going to happen, sir? What is the relative acceleration between A and B? So this is going to be acceleration of A minus acceleration of B. So both have the same acceleration. So obviously the relative acceleration is going to be zero. Relative acceleration is going to be zero. Okay. Okay. So basically both acceleration velocity we see that it depends upon the frame of reference. Okay. It depends upon the frame of reference. But if I ask you this question, that whether if I ask you this question that whether time depends upon the frame of reference, does the time depends upon the frame of reference? What is your take on that? What is your take on that? Does the time depend upon the frame of reference? So you would say no, sir. Time do not depend upon the frame of reference, right? Or time always increase only, na? It doesn't depends upon the frame of reference. It always increases. Okay. So from whichever frame of reference, whether you are sitting in a train, whether you are sitting in a bus, whether you are sitting in a room, whether you are sitting anywhere in this world, time doesn't depends upon the frame of reference. Do you agree or not? Okay. Do you agree or not? Now, if I ask you a few questions, let's say, let's say there is a person A, B, he is running at a speed of 20 meter per second. Okay. And there is a person A, he is running at a speed of 10 meter per second. Okay. Now, can you tell me that what is the velocity of A with respect to B? Okay. And what is the velocity of B with respect to A with their directions? Can you give me that? Please go for it. Can you please give me that? Can you please give me that? Can you please try it? See, we need to understand all these basics. Please tell me. Can you please tell me, the live students? So now please understand this. So now when I say velocity of A with respect to B, so I can do it, formulas with the help of formulas. So whatever comes in the mind first, right? So I can write velocity of A minus velocity of B. Now here I mean velocity of A with respect to ground. Here velocity of B with respect to ground. Okay. Okay. So I can write it like this. So velocity of A is 10. Velocity of B is 20. Okay, so velocity of A with respect to B, velocity of A with respect to B is minus 10 meter per second square. Velocity of A with respect to B is minus 10 meter per second. Okay, not square, minus 10 meter per second. Mashindra, hello, good afternoon. How are you doing, beta? So, I'll tell you what we are doing here. So first of all, welcome to the channel. My name is Dr. Umashankar, and see, I am PhD and MTech from Indian Institute of Technology, Roorkee. Okay. About this channel, so this is an academy channel. Here I am the physics educator, and we are dealing with the physics. So this is the last topic of motion in a straight line. Before this, we have completed units and measurement on this channel. We have completed the vectors, and now we are completing the motion in a straight line. Also, we have done some part of projectile motion as well. Okay, so this much we have seen in this physics in this channel. So we are continuing with the physics. Okay, so today I am telling you the relative velocity in one dimension. Okay, now this is the way. So when I say velocity of A with respect to B, so that means velocity of A with respect to is 2 lagging. What does that mean? So are you not able to hear me properly? Because it seems to me like everything is fine. Can you check your network connection, or can you rejoin the session? Because from my end everything is okay only. Because on my mobile I'm seeing me for your chat. So yeah, everything seems to be perfect. Okay. So you can please rejoin the session. Okay. So what I was saying, so velocity of A with respect to B, that is velocity of A minus B. So just you put this. Now this is minus 10. This is minus 10. So now what happens? So what happens? So when you are observing A, when you are observing A from B, so again you can have the feel of it. This is B, he is running at a velocity of 20 meter per second. This is A, he is running at a velocity of 10 meter per second. So basically, very soon B is going to catch A, right? That means if you feel this way, so the B, or we can say the A is moving towards B. Okay, A is moving towards B, and this you can see like this. This also. So see, B is the observer. So what I told you, whenever you are observing, so whom from where you, so whoever is the observer, you make his velocity zero. So now momentarily we make the velocity of B zero, and we add the 20 in opposite direction to A. So 20 in opposite direction to A. So this will become 20 meter per second. So what is the velocity of A with respect to B? So 10 this direction, 20 this direction. So it become minus 10 meter per second. Okay, right away. Now simply velocity of B with respect to A. So velocity of B with respect to A, what it is going to happen? So velocity of B is 20. Velocity of B is 20. Very good afternoon, AK. Thank you very much. So velocity of B, this is plus 20. It is moving in positive x direction. Minus velocity of A, it is also plus 10. So this is going to be plus 10 meter per second. Right? Okay, so how it would seems to be. So when from A you are observing B, so it seems that B is approaching A by what velocity? By the velocity of 10 meter per second. And we can do by the shortcut only, not requiring to do all this calculation. So what can be done? So we can stop. So we are observing from A. So the observer velocity becomes 0. So we can stop the velocity of A. We can stop the A. So when we stop the A, the velocity of A is going to be added to the velocity of B, but in opposite direction. So this 10 is in this direction. If we add the velocity of A to B, you just reverse the direction. So this is 10, this is 10. So now ultimately this 20, this 10, this will become plus 10 meter per second. Is it fine, Beta? Please answer me. Right? Okay. So this is how you can get the relative velocity. Now let's do one more question. So let's suppose we have a car. Okay. We have a car and this is moving, let's suppose this is car B and this is moving at a velocity of 10 meter per second. So first we try to understand the concept here and then we'll do the question. No worries. See, if concept is understood, the questions is not going to be that difficult. Now this is the car of A and this is, let's suppose, 30 meter per second. Now if I ask you what is velocity of B with respect to A, or what is the velocity of A with respect to B. So you can do it in both ways. Now I think. So can you tell me what is the velocity of B with respect to A? What is the velocity of A with respect to B? Can you try telling me that? Can you try telling me that, Beta? Yeah. What is the velocity of B with respect to A? What is the velocity of B with respect to A? And what is the velocity of A with respect to B? Hmm. Machine wrong answer, beta. See, let's do it very very simply. See, whichever way suits you best, you can choose it. So velocity, when I write velocity of BA, that means velocity of B with respect to A. That is velocity of B when observed from A, whatever way you want to write it. Now see, mathematically I can write this expression velocity of B minus velocity of A. Did you get it, beta? Right? Right? Very simply, B is there, then A is there. So you have to answer me with plus or minus. Now, what is the velocity of B? So see, this direction we consider positive, this direction we consider negative. This is seen, we have seen in the previous sessions that the velocity gives you the direction of the motion. So plus velocity means that something is moving in the positive direction, positive x direction. Minus velocity means that something is moving in the negative direction. Now velocity of B, which I write, so it is plus 10. Now minus on this is the direction of minus 30 velocity of A. When I write velocity of A, it is with respect to the ground. So this is going to be minus 30. So plus 10 minus minus 30. So this is plus 40 meter per second, right? Plus 40 meter per second. Okay. Now velocity of A with respect to B, I can write velocity of A minus velocity of B. So velocity of A minus velocity of B. So this is minus 30, isn't it? This is in negative direction. Minus, this is in positive direction. So minus of plus 10. So this is going to be 40 meter per second. Now what that mean, beta? What does all this mean simply? Please understand this. So when you are observing B from A, when you are seeing the velocity of B from A, it is approaching A at a speed of 40 meter per second, right? It is moving in positive direction from when you are taking the reference from A. See, motion depends upon the frame of reference. Velocity, acceleration, all this depends upon that from where you are observing the motion. Okay. So let's suppose there is a car moving at a speed of 10 meter per second and you are moving at a speed of 30 meter per second. So eventually you are going to collide. Okay. Eventually you are going to collide. Okay. So this is going to be 30 meter per second. This is 10. This is 10. So basically you are approaching each other at a speed of 40. Right. Did you get this or not? Please answer me. This way. I'll just tell you the another way. I'll just tell you the another way. Can you tell me if you get this or not? Yeah, all of you. Those who are watching me live here. Yeah. Okay, wonderful. Now see how we can do it otherwise. See, now, now right away I'm going to do, because see, in examination, the NEET, we need to save the time also. Now, how you are going to write all these things? So we can do it very, very simply. Now please observe. Velocity of A with respect to B. Now in this case, who is the observer? Sir, B is the observer. So you stop the B, make its velocity 0, and you add this velocity to A but in the opposite direction. Did you get this? Now velocity of A with respect to V will become minus 40 meter per second. Sir, how come? Because this direction is negative now. Or you can write the 40 and you can write the direction in the bracket. Okay. If you want to represent in the form of vector, you can write minus 40 I cap, isn't it? Any way you want to do, you can do. Did you get this or not? Please answer me. Did you get this or not? Now, in the similar way, if you want to write velocity of B, if you want to write velocity of B with respect to A, okay? Now, who is the observer? Sir, A is the observer. Stop him. Whoever is the observer, you just stop him, right? Like simply as we are observing the sun, isn't it? So you stop him and you add his velocity to be in the opposite direction. Okay, now how directly it will become 40? No need of calculation, no need of wasting time, and this is in the positive direction, so this is plus 40. Now, did you get this or not? Please answer me. Now, do you feel okay here? Yeah. Did you get this to some extent? Isn't it? The same thing you can do for acceleration also, right? Please answer me. Mashindra, and if any other students is there. Very, very simple, no? See, first of all, we need to understand the concept. Then we can very simply do the question. It is nothing but the velocity only, na? Very, very simple. Yes or no? Right? Now let's try one more thing. Let's differ it a bit. Now let's suppose we have a person. Okay. We have a person. Let's have him as P. Okay. This person is standing on the ground. Okay. This person is standing on the ground. There is a trolley or a car or something like that. Okay. Now this trolley is moving at a velocity of 10 meter per second. Okay. With respect to ground. And there is another person. There is another person. Let's name him A. Now this person A is running on this trolley at a speed of 2 meter per second. Okay, so this 2 meter per second is with respect to trolley. Okay, with respect to trolley. See, when I say, now please understand this. So there is a trolley which is having a speed of 10 meter per second, and if a person is running on this trolley at a speed of 2 meter per second, so this 2 meter per second is obviously with respect to the trolley. Is obviously with respect to the trolley. Now I want you to tell me, sir, what is the velocity of A when observed from P? Yeah, please go for it. Did you get the question? See, there is a person P who is standing on the ground and he is observing a person A who is running on a trolley. We see in the movies, no? Like hero is running over the train in the direction of the motion of the train, in the opposite direction of the motion of the train. So many things like the same way. Right? Now you have to tell me what is the velocity of A with respect to B. Okay? Please go for it. Let's try to answer it. Velocity of A with respect to P. Please go for it. The live students can respond to me. Now see, very simply we can do this. Very simply we can do this. So how we are going to do this? So see, very simple. Velocity of A with respect to P. So we just learned that this is going to be the velocity of A minus velocity of P, right? Because velocity of A as observed from P. So velocity of A with respect to P, that means velocity of A minus velocity of P. Now, what is the velocity of P? Sir, this is 0. This is 0. What is the velocity of A? Sir, this is 2. No. This is the velocity with respect to ground. Please understand this. So, I told you that when I write velocity of A and when I write like velocity of T, simply it is the velocity with respect to the ground. So, velocity of A, this is velocity of A and it is with respect to ground. Okay. Okay. Now I want to have the velocity of A with respect to ground. Now what is given to me? Let's use a simple math. So velocity of A with respect to the trolley. So we know this is velocity of A minus velocity of trolley. This is velocity of A minus velocity of trolley. So velocity of A with respect to trolley, it is 2. Velocity of A with respect to the trolley, it is 2. And this is plus 2 because it is moving in this direction, right? It is moving in this direction. Now velocity of A with respect to ground, I can write here velocity of trolley with respect to ground. This is Vt, so velocity of trolley with respect to ground. So this is in positive direction, so this is going to be minus 10. Now velocity of A with respect to the ground will become 12 meter per second, isn't it? Will become 12 meter per second. Do you agree or not? Do you agree or not? Yes, sir, we do agree to it. We do agree to it. So velocity of A with respect to the ground, velocity of A with respect to the ground is 12. So I can put 12 here. So this is going to be 12 minus 0. So velocity of A with respect to P, it is going to be plus 12. That is when you are observing A from P, it seems to be moving at a velocity of 12 meter per second in positive x direction. Is it fine or not? Please answer me. Okay. Now if I say, now if I say, now if I say, let's twist it a bit. So again, let's say that a person is standing on the ground. Let's suppose this is P. Okay, this person is P. Okay, we have a person here is P, and let's suppose again we have a trolley. Again we have somewhat a trolley. Okay, Now on this trolley we have a person A. So velocity of trolley, let's suppose, is again in this direction. It is 10 meter per second in this direction, 10 meter per second, and it is in this direction, right? Its direction is this. It is moving in positive x direction. Sorry, sorry. So now the A, this person A, let's suppose that he is running on this trolley at a velocity of 3 meter per second, but the direction of it is this. Okay, okay. So obviously this 3 meter per second is with respect to trolley, isn't it? If we say that a person is running on a trolley with 3 meter per second and the trolley moves at 10 meter per second, so basically this is with respect to trolley. Now again you need to give me what is the velocity of A with respect to P. What is the velocity of A with respect to P? Can you tell me that, beta? Velocity of A with respect to P. Please go for it. Please go for it. Let's try it. Let's try it. Let's try it. I'm very sure we can do. Please go for it. Please try it. See, the live students, you need to tell me. See, if we try, see all this relative velocity, you have to think, you have to answer. Please go for it. Please go for it. Please go for it. See how we can do it. So very simply, sir, we need to find the velocity of A with respect to P. So, sir, can you tell us some shortcut to this also? Yes, yes, I can tell you. But let's first understand this way. Otherwise, see, sometimes I have seen that you get confused. See, that was previous one was easy, but this was like you can get confused at times. So, see, we can do it in the proper way. What's the problem? Now we want to have the velocity of A with respect to P. So I can write it like this: velocity of A minus velocity of P. Velocity of A here when I write, so it is the It is the velocity with respect to what? It is the velocity with respect to the ground. Okay. And this is the velocity of p with respect to the ground. So this is obviously 0. Now I want absolute velocity. That is absolute velocity when I say. So here again, two terms are there. Absolute velocity. No velocity in the world is absolute. Any velocity you see, it is with respect to some reference. But in general, when we say absolute velocity, basically we are referring that velocity with respect to the ground. Okay. Now, when I write velocity of A with respect to P, it is velocity of A minus velocity of P. So how it is going to be taken care of? So we want velocity of A. So now here, please observe. Now velocity of A with respect to trolley. So this is going to be velocity of A minus velocity of trolley. Okay. Now velocity of A with respect to the trolley is minus 3 because it is in this direction is equal to velocity of A, and this is going to be minus 10. So velocity of A with respect to ground, it is going to be plus 7. It is going to be plus 7, right? It is going to be what? It is going to be plus 7. Okay. Okay. So now I'll put it here. So this is going to be plus 7 minus 0. So velocity of A with respect to P, it is plus 7 in this direction. Plus 7 in this direction. And if you try to feel it like physically, you also can think of it. Okay. Someone is moving, running towards you on a vehicle which is moving away from you, right? So he is coming towards you at a velocity which is the difference of the velocity of that vehicle and that person. Very, very simple, isn't it? Isn't it? Now let's twist it further. Now let's suppose we have a car. Okay, we have a car here. Okay, okay, and let's name this car as P. Okay, this car is P, and this is moving at a velocity of 20 meter per second. Now there is a person named M. Okay, he is running on this car at a velocity of 2 meter per second. At a velocity of 2 meter per second. Now there is another trolley, train, whatever you feels good to you. Now this is again a trolley or something, and this is having some wheels. Let's say, and this trolley is moving at a velocity of 10 meter per second in this direction, and there is a person who is running on this. Okay, let's say this is A, and this is 3 meter per second. Now obviously this is velocity of A with respect to trolley, so here you need to give me what is the velocity of A, what is the velocity of A with respect to P. Velocity of A with respect to P. Can you tell me that, beta? What is the velocity of A with respect to P? Please go for it. Please tell me. What is the velocity of this A with respect to this car, that is P? Velocity of A with respect to P. How we are going to do that? Let us see how we are going to do that. Now please understand this. So we want to have the velocity of A with respect to P. So the velocity of A with respect to P is obviously velocity of A with respect to velocity of P. That means velocity of A minus velocity of P. velocity of A minus velocity of P. So this velocity of P is 0. Okay, sorry, this velocity of P is 20. Now we require velocity of A. So velocity of A, how I am going to get? So velocity of A with respect to trolley is velocity of A minus velocity of trolley. Okay, so velocity of A with respect to trolley, this is minus 3. This is going to be V velocity A minus velocity of T minus velocity of trolley, that is 10. So this is going to be velocity of A, that is 7. That is 7. So obviously if you put it here, so we are getting velocity of A with respect to this car is minus 13. Velocity of A with respect to this car as minus 13 meter per second. Okay. Now what does that mean? So from A, when you are observing this car, it seems to be moving at a velocity of 13 meter per second in negative x direction, right? In negative x direction. Understood, beta? Understood. Now, in the same case, if I ask you, what is the velocity of m with respect to a? Let's suppose, let's find velocity of m with respect to a. Can you tell me that? What is the velocity of this m with respect to a? Let's think. Let's think and try to answer this. What is velocity of m with respect to a? Please go for it. Please go for it. Velocity of m with respect to a. How we can do it? Please go for it. Please go for it. I'm very sure we can do. Please try to deal with it. So how we can do it? See, again, we have to follow this very simple process. So velocity of m with respect to a. The velocity of m with respect to a. So velocity of m with respect to a. So how I'm going to write it? So this is velocity of m minus velocity of a. Right. So velocity of m with respect to ground, velocity of a with respect to ground. Right. Now, do we have velocity of a with respect to ground? Yes, sir, we do have the velocity of a with respect to ground. So velocity of a with respect to ground is 7. Now we have to have the velocity of m with respect to ground. So the velocity of m with respect to p is 2 meter per second. So we know velocity of m minus velocity of p. Velocity of m with respect to p. So this is 2. This is velocity of m minus velocity of p with respect to ground. So this is 20. So velocity of m with respect to the ground is 22 meter per second. It is 22 meter per second. Yes or no? Please answer me. Yes or no? Right? So obviously, okay. Okay, so velocity of m with respect to p. Yeah, please say you are back, it seems. So velocity of m with respect to p I wanted to, with respect to a I wanted to have. So this is going to be 22. Now this is 7. So this is going to be 15. Okay, your network is fixed. So velocity of m with respect to a is 15 meter per second. isn't it? Okay, so if you observe the M from A, if you observe M from A, it seems that the person M is moving in the positive x direction at a velocity of 15 meter per second. At a velocity of 15 meter per second. Is it fine, beta? Please answer me. Right? Please answer me. Please answer me yes or no. Right? So now, did we get the basic of relative velocity in 1D? Right? How to deal with the relative velocity in 1D. Now, there are some uses of this relative velocity in one dimension. This is also the basic of relative velocity in two dimension also. So we see like thief and police problem, relative velocity. We'll later see umbrella man problem. These all are the outcomes of relative velocity. Okay. Okay, so I'll keep it to this point in this session so that you get something of the relative velocity, and I'll come up with the in the next session of this relative velocity. I'll tell you to apply this in police thief problem and all those things like motion in the gravity problem also can be applied. Okay, so in today's session I'll give you just the velocity. In the coming session I'll take up the acceleration also. Okay. Okay. So I'm stopping the session now. I have given you all. See, I can say the relative velocity in 1D is completed. Concepts are completed. Now questions can be any number, right? The same funda you can apply for the velocity. Same funda you can apply for acceleration. So we may do the question in the 75 hard day challenge as well. So whatever it is, I'll come up with some more questions. We'll have some more questions of relative velocity in 1D. Meanwhile, you can, huh, no problem. No problem, Shizai. So meanwhile, you can do what? You can just go through this video and you can understand the basic concept of relative velocity. Although I think it is going to be, it must have been very clear to you. It's a very simple concept. Okay. Okay. So in the coming session, we'll be talking more about it. And after this, some questions is left. So we can say the motion in a straight line is completed. This was the last topic. Funda is clear, concept is clear. Now the questions we can do in the hard day challenge thing, or I can make one session separately of the questions of relative velocity. Okay. Okay. So with this, thank you very much. Have a good day. Please, the new students, I request you to subscribe the channel. Please share it. Please like it and help us grow the channel. So with this, thank you very much. Have a good day.